CryptoLib hands-on. So I propose first to launch just an example from the packages and see that it's executed properly. Then I will propose to start from blank project and try to add the library, the header file, and implement a basic code example. I think it's a basic use case, but it's good to know how to do this. So let's switch to QBDO. So first I propose to launch an example on the L152. You will see that there is some Atomic example for this one, so easy to import in STM32 QBDO. And unfortunately, on the L4, there is not any Atomic project, so I propose then we will port on another board, and we will see how to integrate everything from the start. Okay, so first, let's try to import a basic example that is available in the package. So if I am in the package and I say I want firmware crypto for the L1, the project, let's take iOS CCM for example, and there is already a True Studio version, so we can just import it. So if I have a look in the main.c, so there is some vector test defined, encrypt iOS CCM, encrypt iOS CCM, decrypt, a buffer comparison. You remember you have to enable the CRC clock before using the CryptoLib. Then there is an encryption. If it's working fine, we check the content of the output message if it's as expected. If it's not, we switch off the LED, and then we decrypt the messages, we check it's good, and if it's good, at the end we should have the LED which is switched on. So let's compile this. It has been already cleaned, so I prefer just to restart. Let's build it. Then we can debug it. So if I step over, oh sorry, there is optimization, so you can see some jump, I would say. So if I just continue, I can have a look and have my LED that is on, so the algorithm is okay. So let's stop debugging. So let's have a look how to use. So here we've got a function that is already implemented on the L1. So I propose to port all this stuff on L4. So where is the header? Just to understand what we will have to do. If I open it, we just need to include crypto.h, and all the rest should be in line. Okay, perfect. So I propose now we start a new project for the L4. So the board I selected is the L476RG. So let's close this project for the moment. Project close. Okay, and let's create a new one. So it has board selector L476. That's the CryptoLib. Okay, so we planify to use it with the CryptoLib, so we have to enable the CRC. This could be done thanks this in the computing. Just say, okay, I want to activate the CRC. Keep this in mind when you are using CryptoLib for sure. And I think that's it for the pinout. Nothing else to be done. Okay, so our project is ready. Before adding any code, I propose that we will add the library to the linker. So here we just go in the properties. Then we should go in accessible settings. Then you've got tool settings. We won't use the version with floating point unit, so we declare no floating point unit and a sub-pure software implementation. Then in the linker, we just need to specify here which library we want to take. Okay, so here I will just put the library path, who by default is already done, but you can use, just update it with the good one, so STM32Cube extension. We are on a pure software one, the L4, middleware, STM32 cryptographic include. Okay, it was not include, sorry, so let's update it. It was lib. Okay, so this one is a good library path. Okay, and now I will add the library name. So here it's a little bit, I would say, not tricky, but it's to know. If I open the folder where I store the library, the GCC one, I've got lib at the start, okay? So in this name, you have to remove this lib and just give without any extension. So I just copy this name, so it's the name of the library I want to include, and I just put it there. Okay, so remember to remove the lib that is before on the .a at the end. Okay, I think that is the main things. Now we will update the include path because we will also do an include crypto.h. So for the include path of the GCC here, we will add another one. So regarding the file system, so here in the cryptographic, we'll include the inc file, okay. It should be, okay, this one. And here I put some absolute path, but the better things would be to to do a copy of the library and all the middleware inside your project, and then to put some relative paths, but here is to go quicker. So if I apply, I think everything is ready. So now I propose just to add this include macro in our code. So in my main.c, I will just add, I miss it, okay, just include crypto.h. I propose to have a look in this file. So as you can see, or you will be maybe surprised, okay, it's definition of what we should include it. So the different algorithms, okay. What I would like is to have a look in the config.h, and in this one, so you see it's Cortex, and you can see that it's defined for IRR. In fact, I include the path of the L4, and in the L4, it's defined by default in this configuration file for IRR. So here we have to modify it and say that we are using GCC. So here we just put a command this one and define this one. Okay. So now the configuration file is sure that we are for GCC and we don't face any issue. Perfect. You can find many details about this configuration on this crypto.h in the reference manual. So now I think we could try a first build just to check the status. It seems okay. So now I propose to port the code that was in the L1 project. So here I will just do some copy paste. The interfaces is the same, so it's really an advantage of the CryptoLib. If you need to do some migration from one family to another one, it was one API interfaces. So here I will just take all this stuff. So the definition of test vectors or value expected, the output messages, okay, not the GPIO, and I will put this in my example, so like private variable. I will also declare those private functions, iOS decrypt, buffers. So this is the 3 functions that I will have to copy. So the prototype. Okay. Then I will need the implementation of those 3 functions. So it will be at the end of this folder. Got it. Yes. iOS encrypt. Then I've got the iOS decryption and the buffer comparison just after, and the buffer comparison. I can copy them also. So usually at the end we've got user code to be put. Okay, so here I will say all the different functions. Now let's go in the main and just copy the algorithm from the main. So main Cisco let config, it's already down in my initialization of the LED. I want toggle, the CRC enable should be in my code already. I will just do the encrypt, check the status, decrypt, check the status, and write pin. Okay. So I go back in my main. Here my CRC is enabled here. I can just copy paste all the code here. I think there is the one missing point was the declaration of status, if I will remember. Here, this one have to be copied also here. Okay. So I propose to try to build. It seems to work. So now let's try to debug. Everything by default should be okay. Debuggers is connected. Let's do a step by step. After encrypt, status is okay, buffer comparison is okay, decryption authentication is okay, and it was working. Okay, so just I would like to have a look in the different variables just to check what are the. So the output messages. Sorry. So here we've got a comparison between the ciphertext and the output text. Okay, and here we do output messages, decrypt data in AWS and check authentication tag. It was decrypted and had input. We've got the output message, so it was crashed here, so we can't test. But I would say we were turned on the green LED, so the loop was okay and the operation was successful. So I finished my hands-on. The purpose here was to show you how to easily port from one platform to another, and with CryptoLib it's quite easy. I also want to show you how to create a project from scratch and how you can just integrate the library, which is quite simple when you've got these tips. Thanks for your attention.